I'm going to move along and I'm going to kind of summarize everything that I just said right there. This property that I've been talking about, gases moving around in this chaotic way, this is called diffusion. It's the transport phenomenon that describes molecular motion. Okay? And if we could track a single gas particle moving around through air, its motion would look something like this, right? It kind of zips along chaotically. Okay? It doesn't move in this 1,000 miles an hour straight that way. Okay? And as it turns out, all of these little chaotic moves right here, they each are on average about the same distance. Okay, so let's say, from like this point to this point, okay, that's on average about 65 nanometers. That's 6.5 times 10 to the minus 8 meters. What does that mean? That means every 65 nanometers, a molecule is colliding with another molecule, which is part of the reason why they've got all this crazy motion. They're colliding with each other all the time, and they can't go into a straight line. Okay? So mean free path, the average distance a molecule travels between collisions with other molecules. So at STP, remember STP, standard temperature and pressure, it's about 65 nanometers. That's tiny, teeny, teeny, tiny. So even though molecules move incredibly fast, diffusion is very slow. And the reason why it's slow is because molecules can't travel in this straight line trajectory. They're constantly being moved around, changing directions, okay? And that's why, for example, in terms of how we smell things, there's a delay, right? If let's say somebody's cooking in the other room, that smell doesn't get to my nose instantly. There's a little bit of a delay because of this diffusion being very slow, even though the molecules themselves are moving very fast, okay? And effusion is the process by which a gas escapes from its container through a tiny hole into a region of lower pressure, okay? So for example, if I had, once again, a balloon, right? And this balloon has a teeny, tiny little hole, right? We pop it. The molecules effusing out of this hole are also going to have this kind of crazy, chaotic pattern. Okay? So that's all that I really want to say about diffusion and effusion. The books give you some calculations and stuff to go through, but just conceptually for me, understanding diffusion and effusion is fine. Okay.